All right, hello. We are going to start our next unit on functions, and the first lesson in this unit will be graphing relationships. Okay, so we're gonna learn how to match graphs with situations and then graph relationships. All right, first thing I want to do is take a look at a video and ask a question or two. So we'll pause here and watch that video. All right. So how do I represent real-world situations with a graph? Let's just kind of take a look at this situation. Each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves. Eventually, there are no more leaves on the tree. Okay, which of these three graphs best represents the situation described there? We'll pause here. Okay. So really there are two main types of graphs that we'll be talking about in this unit. And the first is continuous graphs. And a continuous graph is a graph that is connected by lines or curves. And we use these when fractions and decimals are allowed. So if we take a look at this graph here, is graph B, it says, is temperature graphed over time. And we know that temperature could be 72.8 degrees, so we can have fractions or decimals. So that's a continuous graph. You would graph it without lifting up your pencil. Discrete graphs, these are graphs that are only distinct points. They are not connected. So you'll see here, the theme park attendance is the title of that one, and you'll notice it's people graphed over a number of years. So here we would graph people would be a whole number because I would not have half of a person or anything like that. So it would be a whole number, and so therefore we would use a discrete graph. Okay. And then here are just a couple more examples. If they give you said, hey, track, a small bookstore wants to track the number of books it sells each day for 7 days. Well, because we can only sell whole number of books, then that would be just distinct points there. And the second one has a truck driver enters a street, drives at a constant speed, stops at a light, then continues. So we can have fractions or decimals. We could be traveling at 52.5 miles an hour. So that's continuous. You should be able to graph that without lifting up your pencil. So just kind of keep that in mind when you're graphing. Is this continuous or is this a discrete graph? Okay. The other thing that's really, really important when graphing is to pay close attention to the labels on each axis and what they're asking you to do. Okay. So that's really important because your graph will look a lot different depending on the labels. All right. And you'll notice here on the left, I said that again, variables are important. So keep that in mind again as we go. All right, here it says sketch a graph. For each given scenario, Azaria drives a school bus. On her morning route, she stops at every block to let students on. Graph time on the x-axis and the total distance the bus travels on the y-axis. Okay, so down here, I'm going to write time. And on the other axis, we'll put distance traveled. Okay, so here we go. We're gonna plot our course. Okay, so Azaria is going to start, distance travel would start at 0. Okay, she's gonna drive to her first stop. Okay, then at that point, she's gonna stop, but that means her distance won't change if she stopped for a little while to pick up some students. So we're gonna have a straight line, and then she's gonna continue on to the next block. Okay, And then again, pick up some students, stop for a bit. And this will continue. We don't know how many times this is going to continue. So we're just going to do this a few times because they don't give us any more information. Okay, so again, just kind of keeping in mind, making sure that it matches the scenario that we have there. And based on the information that we have, that might be as far as we could go. All right. And again, I know that this distance is continuous, so hopefully that makes sense that that's a continuous graph, as my distance could have fractions or decimals. All right, let's move to another one. Here it says a pizza shop on a college campus tracks how many pizzas it sells each day for a week. Graph time in days on the x-axis and number of pizzas sold on the y-axis. All right, so time in days, and then this is number of pizzas sold. Okay, now this time they're tracking the total number of pizzas sold, so that would be a whole number. So this one is going to be a distinct graph. Okay, so day one, let's say day one somewhere, we don't know. It's not tracking. They don't tell us if it goes up or down, so you can kind of make this up. They just say they're tracking this. So we're going to say day two. They do this for a week, so that means I'm going to have 7 dots. Let's say it stays pretty close to the same. 3, 4, 5. Okay, maybe it goes up as we get to the weekend. Okay, and so there's our graph, and notice that that is distinct. A discrete graph, so distinct points. All right. Okay, lastly, I want you to take a look at this situation. These are 2 graphs that represent the exact same situation. And this is a child going down a slide. So why do these 2 graphs look so different? We'll pause here. Okay. All right. So what I would like you to work on now is an assignment for graphing relationships and making your own graphs and then matching graphs as well. And when you're done, submit it to Schoology. All right, we'll see ya. Bye.